All right, so I want to talk about some considerations when you're planning out your set of stairs. And so, generally speaking, wider treads, shorter risers are very comfortable. Um, Both of those things, however, increase the total run. And we don't always have unlimited space to put a set of stairs in. Okay. Once we make the treads narrower, make the risers taller, we decrease the total run. Okay, so there's always this compromise that we're trying to find. Um, the generally accepted ratio is 7 and 11. 7-inch rise, 11-inch tread. Okay, and there is, I would say, such a thing as too much tread depth. Okay, once you start getting really deep treads, you start getting confused about am I supposed to just step really wide up these stairs or take 2 steps per tread? So 7 and 11 is kind of the target, I guess, for a set of stairs. It's comfortable for most people, and it takes up a normal amount of space, I guess, if there's a normal amount of space with a set of stairs. The biggest thing, though, we're always constrained with these things here, okay? We can't exceed 7 3/4 inch unit rise, and we can't have any less than 10-inch minimum unit run, okay? We can go bigger than 10 inches, we can't just be narrower than 10 inches. Okay? And we need to have 6'8" headroom. So when we are descending or ascending the stairs, okay, from the nosing to the ceiling above us, we need to have at least 6'8" of headroom. Okay. When we are trying to determine the total rise, remember that's from finished floor to finished floor. Most of the time, inside a house, we have similar floor thicknesses, or they're similar enough that it could be maybe fudged if it didn't turn out exactly right. It gets really bad on the outside when people don't take into account finished floor thicknesses. And mostly I'm talking about a deck. So I'll talk about, let's say we're building a set of stairs on a deck, and that set of stairs is going to terminate at like a slab or the dirt or whatever the case may be. And so you're not going to add any finished floor thickness to that. Okay? But if you're measuring to, let's say you've got the deck frame kind of rough framed in, and you're measuring to the joist or something like that, you're going to add 1.5 inches of thickness to that rough floor. Okay? That can cause a huge discrepancy. Okay, so you need to take into consideration that finished floor thickness, okay, or dimension. All right. If I were getting ready to build a set of stairs inside a house, and I wanted to determine the total rise, what I would do is get a piece of wood that is the thickness of the lower floor, and I would get a piece of wood that is the thickness of the upper floor, and I would butt my tape measure on the thickness block for the lower floor and measure up to the block that represents the thickness of the upper floor. That would be my total rise. The way we attach the stairs can determine how many treads we have. It can determine a couple things with our sets of stairs. So one thing that's most of the time kind of nice is if we use the second floor as the last riser and tread. Okay, so like what's represented in this picture. Okay, the stairs come up, and we're using that second floor as the last riser, the framing as the last riser, and then the actual floor on the second floor as the last tread. Okay, when we do that, keep in mind that we're going to have one fewer tread than we will riser. Okay, we're still taking into account this in our total rise, okay? So the floor is acting as the last riser, but we're not going to have this last tread, okay? This looks nice on the inside of the house. Right? An alternative, and this is gone over a little more in the book, but an alternative is to actually build the stair stringers into the floor framing, and that makes for not only a great way to attach the floors, but an aesthetically pleasing way. And that's mostly if we're talking about like a deck outside, then it kind of looks like the stair stringers are just tacked on to the deck if it's all the way up at the same elevation. Okay, it's kind of nice, like on an exterior set of stairs, if you can build the stringers into that floor framing. Okay, we always want to notch the bottom of the stringer over a kickboard or a thrust board. There is an awful lot of weight and force exerted on these stairs as someone is going down the stairs. If you have people running up and down the stairs, heavy people on the stairs, there can be a lot of weight on these stairs, and they can fail if they're not properly attached. Okay, so properly attaching it at the top, we'll talk about a couple of different ways to do that, but this is really critical no matter what you're doing with your stairs. You always want to have this kickboard. Okay, if you're going down the stairs, the stringers are wanting to push this way, and if you cut a notch out of all the stringers and nail a 2x4 down to this bottom floor, the stringers are notched around that, nailed into that board, they're not going to be able to push through here. Okay, if this toe board wasn't here, in theory, these stairs could slide out this way if there's nothing holding them there. All right. Let's go over some math for laying out a set of stairs. And it's fairly basic. Okay, you could do this math on your own as long as you know how to convert decimals. And then I'll kind of walk through the Construction Master calculator with you for figuring out the stairs. So let's say our total rise is 106 inches. And that's going to be finished floor to finished floor. First floor, finished floor to second floor, finished floor. 106 inches. We want to figure out how many risers we need. I like to start out by dividing the total rise by whatever the max unit rise is. Okay? We want to try and max it out so that our stairs take up less space. Okay? So if we go 106 inches divided by 7 3/4, that's going to give us 13.67 risers. Okay? We can't have 0.67 of a riser. Okay, so do we want to have 14 risers or do we want to have 12 risers? Okay, that's the million-dollar question. We want to round up to 14. Okay, if we round up to 14 risers, that's going to make that unit rise less than 7 3/4. If we went down and said, okay, we're only going to have 13 risers, okay, we're ascending quicker, which means we have to have taller risers, and that's going to make our unit rise exceed 7 3/4. All right, so we've determined that we're going to have 14 risers. Now that we know that we're going to have 14 risers, we can figure out what our actual unit rise is going to be. Okay, so our total rise hasn't changed. It's still 106 inches. We know that we want 14 risers. When we divide 106 by 14, that's going to give us 7.57. Okay? 7.57 inches converts to 7 9/16 inches, okay, which is less than our 7 3/4 inch maximum rise. So that's a good number, okay. The ideal number, I would say, is 7, okay, but we're close to that. I would say if I were actually going to build this thing, I might play around with it a little more and see if it was like, what if we did 15 risers and see what that number is. Well, I can figure it out here real quick and tell you. So if we went 106 divided by 15, that would give us 7.066667, okay? 7 and a 16th. If I had the space, I would probably do that. I would probably do 15 risers. I'm going to lose a little bit of floor area because my stairs just got longer because I have an extra riser, which means I'm going to have an extra tread now also. The reason I would probably try and do that is because not only does that get us closer to that kind of golden number of 7 inches rise, but as soon as the closer we get to 7 3/4, the more we lose some wiggle room on this thing. Okay. Inspectors are generally pretty unforgiving with stair codes. Okay. So, but anyway, let's just stick with this for now. We've determined that we want 14 risers. Our unit rise is going to be 7 9/16. We got that by dividing the total rise by the number of risers. Let's figure out what our unit run is. Let's say it's 10, okay? That's the minimum. By the time we add a nosing, it's going to end up being like 10 3/4, 11. It'll be very comfortable, okay? We can determine the total run by multiplying the unit run by the number of treads. And so this is where it can kind of get a little tricky. And again, it's going to depend on how you're attaching these stairs. In the previous slide, we looked at the stair stringers hanging off the second floor so that the second floor counted as the last riser and tread, okay? So we're going to have one fewer tread than riser, okay? We had 14 risers. One fewer tread than riser is going to give us 13 treads. We've got a 10-inch unit run. 10 by 13 is 130. So our set of stairs is going to occupy 130 inches of floor space. Okay, that's the horizontal run, the total run of our set of stairs. If we wanted to go further with this, we could figure out what we wanted our stringer length to be. Okay, we've got a rise and a run, and we use the Pythagorean theorem to figure out the diagonal. Okay, so 130 squared, 130 is our unit run, plus 106 squared, that's our unit rise, gives us 28,136. The square root of that is 167.73, which ends up being 14 feet. Okay, so this is handy because I'm going to build a set of stairs. I want to know how long my stair stringers are going to need to be. I can go to the lumber yard and get some 14-foot 2x12s to build my stair stringers. All right. Everybody get their Construction Master calculators out, and we'll go through this together. So if I were using the Construction Master calculator, I would punch in 106 inch rise, and then all I have to do is hit the stair button, stair. Right? It would tell me my riser height, 7 9/16. If I hit stair again, it would tell me I need 14 risers. Hit stair again. It says I have an underage of 1/8 of an inch, which means I need to lose 1/8 of an inch somewhere on the set of stairs. What I would probably do is make the first riser 7.5 and the last riser 7.5. They're both a 16th inch under. That's my 1/8 inch that I need to lose. I've broken it up over a couple of steps so you wouldn't really notice that. If I hit stair again, I've got the pre-stored 10-inch tread width in my calculator. And hit stair again. It tells me I need 13 treads. Okay. It tells me I need, if I keep hitting stair, it's going to give me more information. It tells me that the stairwell opening needs to be 119 inches. And so what that means is from the wall where our stairs are going to end, if I were to butt a tape measure into that wall, like at the top of the stairs, and measure over 119 inches, that's the opening I would need in that second floor so that I could go down the set of stairs and maintain 6'8" of headroom the entire way. Okay, so that's a pretty handy function. And if I hit stair again, it tells me I need 163 inches of stringer length. It hits stair again, it tells me the angle of inclination, 37.10 degrees. That'll be handy when I'm doing finish work on the stairs and I need to determine what the miters are, okay? And it tells me my run is 130 inches. So there are some preset numbers with this calculator, and I can't remember exactly where they are. So I would recommend watching the stairs YouTube video for the Construction Master Calculator. But you can change the maximum riser height. You can change the tread depth. So let's say you're doing a residential set of stairs and you want to have your max unit rise set at 7 3/4. You can program that into the calculator. If you're doing a set of commercial stairs, you can change your max rise to 7 inches and your tread depth to 12 inches, and it'll build the set of stairs for you based on those numbers.